Welcome to clickmyproject.com. Now I am going to explain the exact solution of the environmental or economic dispatch problem. Now we are going to discuss about the concept of this paper. In this paper, the multi-objective optimization in electric power systems treats the economic and emission act as competing objectives. Economic load dispatch is one of the most significant optimization problems in modern computer-aided power system design. In this paper, we propose genetic algorithm GA to solve the economic load dispatch problem with non-smooth fuel cost curves considering transmission losses, power balance and capacity constraints. This problem was solved using linear programming. This approach consists in optimizing the preferred objectives and treats the others as the constraints. First, we take into the account the unit capacity constraints in the exact formula. Second, we obtain the set of compromise solutions known as the Pareto optimal solutions. And third, our main aim is to minimize the transmission losses for maintain the power balance constraint. This is the flow diagram of our process. First, we are going to start the process. Then next, we consider the optimization problem. Here, optimization problem means the multi-objective optimization problem. It's also known as multi-objective programming vector optimization, multi-criteria optimization, multi-attribute optimization of Pareto optimization in the area of multiple creative decision making, that is concerned with mathematical optimization problems involving more than one objective function to be optimized simultaneously. Multi-objective optimization has been applied in many fields of science including engineering, economics and logistics. Then minimizing weight while maximizing the strength of a particular component and maximizing the performance while minimizing fuel consumption and emission of pollutants of a vehicle or example of multi-objective optimization problem involving 2 and 3 objectives respectively. In practical problem, there can be more than the objective functions. Multi-objective optimization is a optimization of conflicting objectives. Then next we go to the Pareto optimal function. Here we consider the Pareto optimal set. From that only we get the Pareto optimal solution. Concept of Pareto optimality underlies the values independence used to choose among alternative resources location, alternative economic states with the greatest net benefits. Pareto optimality is a state of the economy from which it's impossible to make one person better off without making another person worse off. If society finds itself in a position from which there is no Pareto improvement, then there is a Pareto optimum. Pareto optimality is the state of allocation of resources in which it's impossible to make any one individual better off without making it at least one individual worse off. For example, suppose there are two consumers A and B and only one source is we used. Suppose X is equal to 20. Let us assume the source has to be distributed equally between A and B and thus can be distributed in the following algorithm. Then next we apply the genetic algorithm. In genetic algorithm process, we consider the 5 steps. First, we go to the initialization process. The first step is the optimization is to create an initial population of candidate solution by assigning random values to each decision parameter of each individual of the population. Next one is the mutation. After the population is initialized, the mutation operator creates mutant vectors by attributing a randomly selected vector with the difference of 2 other randomly selected vectors. Then the next one is the crossover. It uses binomial crossover operation of this crossover constant. CR is an algorithm parameter that controls the diversity of the population. The crossover operator creates the trial vectors which are used in the selection process. The next one is the evaluation process. Next step is evaluation. In order to increase the diversity of the attributed parameter vectors, crossover is introduced. To decide whether or not it should become a member of generations, the trial vector is compared to the target vector using the greedy criterion. Then the final one is the selection process. The selection operator forms the population by choosing between the trial vectors and the predecessor. Those individuals that present a better fitness are more optimal. Then next, the process is checked and to overcome the optimization problem and find the best solution. Now let's be going to discuss about the implementation of this process. This is the MATLAB command window. These are the files used for our process. Then main is the main function file and others are the sub-function files. Click the main function and choose run file option. Now we are going to denote the lambda value, because from the lambda value only we calculate the total cost. Give any value. So first we go through one by one graph. Then this is the genetic algorithm graph. From this we find out the fitness function value and the current best individual for the generation and number of variable functions using genetic algorithm. The next one is the Pareto-French solution. For Pareto-French solution, total emission, the graph is between the total emission and the total fuel cost. Then the cost is decreased. This is our main concept, and the losses also decreased. The next one is how the objective functions are placed in three figures. In this we have three objective functions. So first objective function, how it's placed in figure 3, and next one is figure 4, and the third one is figure 5. Then this is the analysis of for the economic dispatch problem. So first consider the first table, consider the economic dispatch without transmission losses. So here consider the power demand as the 900 megawatt. The next figure is the economic dispatch with transmission losses, but power demand does not have any change. The next one is the economic dispatch with transmission losses. Here we change the power demand as 1170 megawatt, and also the same thing for last table, that is without economic dispatch without transmission losses. Then it's for 1170 power demand megawatt. Click the analyze button. Then we choose the generation for 6 units, 1, 2, 3, 4, 5, 6, and the total fuel cost and the total emission. From this we conclude that the environmental economic power dispatch problem was investigated. The multi-objective problem is converted into single objective from the means of price penalty factor with the consideration and problem constraints. Thank you.